They're the yin and the yang.
Yes. Yes. It is like kind of, yeah, it's what you want to look at and how you look at it. Because they are still killing that cell to release those nutrients. That is what's happening.
I'm an ichthyologist. An ichthyologist is a type of biologist that specializes in studying fishes. Imagine during the pandemic, this was kind of hard. Falcor was on its way to Papua New Guinea to do a bunch of research there when the pandemic hit. So connected digitally, like they can stream all their video and stuff. Nobody actually had to get on the boat to do research. There's a underwater robot called the ROV Sebastian. Scientists or other folks involved that are providing commentary or talking, so kind of explaining what people are seeing. It's a really cool opportunity. They started it, you know, they weren't really thinking about fish. They were pretty interested in the rocks and the coral and stuff. But there's a live chat on the YouTube. Started identifying the fish, talking about the fish. We took over and we called it the Fish Army. Team Fish showed up and we were there, kind of dominating the chat and identifying a bunch of really interesting fish.
State of the art in cyber defense. At least for the last year during COVID, this tiny little office space is my current cyber Thunderdome.
Wait, hold on. Wait, I want to show you guys the cyber Thunderdome. Hold on. Cyber. I'm inside the cyber Thunderdome.
Most conventional thinking around cyber defense is that if you tell an attacker what your defense is, it becomes less effective. But what we've shown is that for these kinds of defenses, these game theoretic defenses, use of defensive deception, defensive mimicry, by telling the attacker we're using the technique, it makes it more effective, which is awesome.
As an aerospace engineer, I was one responsible for designing some of those aircraft engines that are out there. You hear that sound up there? That's an aircraft engine. So that's where all the power in an airplane comes from. So I went to the University of Michigan, where our football games had 111,000 people at each football game. And while I was there, they actually redesigned the stadium. So instead of all of the noise bouncing out into the city, it kind of bounced into the field. 111,000 people all cheering for a football game, but you actually have people living around that city as well. So even just like this, when you have airplanes flying over and people are living here, you have to think about those things and you solve those problems.
Some of these environments approach the near limits of life. The place I study is one of those places, the Dry Valleys. It's a place in Antarctica that is the most Martian-like place on Earth. Requirements for life as we know it on Earth, right? A set of chemical elements. The second is an energy source, and the third is water, right? For a long time, we view this energy source as the sun. Earlier notions of what and where life could exist, right? Life needs light. It doesn't actually. Surprisingly, life needs an energy source. It doesn't necessarily have to be light. You find ice, water ice. Most people think of ice as water ice, but in space, ice is a whole different set of mixtures. Gained a little bit of knowledge, but I hope you gained a lot more curiosity. So please come talk to me May 1st. Follow the Zoom link, and I'll be there to answer questions. Keep on sciencing.
Hi, everybody. I'm Molly Matty, Dr. Molly Matty, or as Jean calls me, Dr. DNA. And if, you know, money's tight, like money was for me, you can go to graduate school and get paid to be a student. The beauty around you and asking, why does this butterfly's wings look so different from other butterflies' wings? How do they get that really shiny color? It's actually because of really cool structural chemistry. And so if you find that you've become obsessed with the blue morpho butterfly, maybe you want to be a chemist and study structural chemistry, and you could design dresses that suddenly have this shimmering effect that you got obsessed with because of a beautiful butterfly. You might learn in school that so-and-so discovered something. It's never just one person. When I'm showing you the work that I do with my worms, I'm in a lab full of really cool, interesting, diverse people with new ways of thinking and unique skill sets.
Our cars less, and we have to hold the people that are emitting those carbon dioxide emissions responsible for their actions. I always like to refer back to the basics, which are the 3 R's: reduce, reuse, and recycle. And if you actually think about those 3 R's, they're in the order of how important or how effective they are, right? So the first thing we can do is reduce our usage of things like disposable items like hand sanitizer bottles or disposable bags. Those are things that we can do first and foremost, is just reduce our usage of things, including things that emit CO2 directly, like driving our cars, using power for electricity, turning the lights off, using nice sunlight instead of direct light. All of those
design and build telescopes, microwave telescopes, and this is right between infrared and the radio. We're in this weird little no man's land between them, all in the pursuit of learning about the earliest moments of the universe. And so if you go back in time all the way to the beginning of the universe, you'd have this incredibly hot, dense environment, and after a few 100,000 years it cools off enough that it's able to release light out to the universe. And that's been traveling to us for 14 billion years, just about, and that's what we're able to see now. We're looking at telescopes as time machines is a great thing because, yeah, light travels at a finite speed. So any telescope anywhere, you're looking back in time to how things were. So if I remove that cover, that's effectively our lens cap.
Oh, wow.
If you took that off, you would see the window, which is just the vacuum window that keeps the air out and the cold in. Our photoplane where we put our detectors, and that's in at 0.1 Kelvin. So just like inches away from my hand is about probably the coldest thing. I don't know. It's hard to know how far, because now with quantum computing they use similar resources, but it's certainly one of the coldest things in San Diego right now, if not one of the coldest. And then up here, this whole section is 1 Kelvin and below inside here, the optics, which are also just inches away from my hand. I feel like I can say with more confidence that this is the largest volume at that temperature, probably within a few 100 miles. Because most places only cool down a very small area.
How cold is that?
How cold is that? Really, really cold. So, you know, this is the fun thing about the Kelvin scale. If you're not used to it, it's basically what physicists use, because it's an absolute scale in that 0 is as cold as you can get. There is no negative Kelvin. 0 is as cold as you can get in the universe. And this gets into temperature is basically a way to say how much are the atoms and whatever else that composes it moving and vibrating around. It's an energy.
Right.
And so 0 Kelvin is it's 0 energy. They're absolutely still, you really can't get there, but you can get pretty darn close. And so we get pretty darn close, which is about 1/10 of a degree above absolute 0.
Yeah.
And in Fahrenheit, I always forget the conversion, but something around negative 460 degrees Fahrenheit.
Jeez.
So it's
Whoa.
chilly.
Dang.
So yeah, this is the vacuum. Your little mast that's sitting up there is to mount a sensor that detects magnetic fields. So we're curious if magnetic fields. Come join us on the Zoom link on May 1st, where you can ask me and other scientists all sorts of fun questions that you have from the research we're doing.
How scientists observe the ocean means everything for what we're able to know about it. Study the microbial loop in molecular and genetic detail with the modern tools of biology, but we still use this sampling ladder and go down to the bottom of this pier with our nets and buckets, and take the material back to the laboratory. So let's
go get a bucket.
Yeah. it's really inspiring just to look at biologically what's going on around here. Implementing automated technology that will lead to higher resolution temporal sampling of microbial communities. Here, it's split, and one sample can go over here to this is a membrane inlet mass spectrometer.
Quite a step up from a bucket.
Right.